Hello everyone, welcome to the fourth lecture in this series. In this lecture, I will be introducing you to arrays, which is one of the linear data structures. In the very first lecture, I introduced you to different data structures and its categories like linear and non-linear data structures, and array is the best example for linear data structure. In a linear data structure, elements will be stored in sequence and every element will have a preceding element and will have a following element. So, array is actually a list and array is actually an abstract data type as well. I hope you remember in the first lecture I told you what abstract data type is. Abstract data type defines the set of operations that can be performed on any data structure, and in case of arrays, the operations which we normally do with arrays include insertion of an element into an array, deletion of an element, searching for an element, modifying an element, and even maybe traversing the entire list of elements in an array. So, in this lecture I will be giving you an introduction to arrays, how we actually represent arrays in memory, and two basic operations which we do on arrays, namely accessing an array and traversal in an array. So, first let us see the introduction. Array is an example for linear data structure, and in an array, as I said, it is a list of elements and all the elements will be of the same data type, and so we say that an array is homogeneous. An array falls under the category of data structure which we say as collection, which means it has a bag of elements and all the elements in the array will be stored in contiguous memory location, that is at adjacent memory locations. Say for instance, if I have an array of 5 elements and all those 5 elements will be available in sequence in memory, and all the data items constituting an array of elements will be usually sharing the same name. For instance, if I have an array of 5 elements and all those 5 elements will be denoted by the same name, but individual elements index or position within that array would vary, and in order to access an element individually from an array, we will be normally specifying its index. So, here in this example you could see I have declared an array X with size 10. So, this array would have capacity to store 10 elements, and you could see that the array index always starts from 0 and I have 10 elements starting from x of 0 to x of n. So, in order to pinpoint one specific element, say third element in the array, then I should call it by its index which is x of 2. These are some of the characteristics of an array. So, here every value in that array we call it as element or an array's element. The total number of elements in an array we call it as the array size, or in other words we will even call it as array's length, and each element can be fetched uniquely from an array by specifying its position, which we also call it as index, and always an array's index starts from 0. So, here the 4 factors you should know with an array, like elements denote every member of an array, and every array will have a size or length, and in order to retrieve an element uniquely we need to know its index, and always the index starts from 0. And we always say that an array is ordered and fixed in length. So, the reason why we call it as ordered is that when we place or add some elements to an array, it will be always in the order which we have added the elements to that array, and always the array size is going to be fixed. In that sense, we need to specify the size of the array during compile time, and once we have defined the size of the array, we can neither shrink nor expand its size. So, here in this example you could see I have defined an array with name as array and size as 10, and this array's data type is going to be integer. In that case, in memory there will be space reserved for all these 10 elements of size integer, and all these elements will be stored in sequence in consecutive memory locations, and I can never in future alter the size of this array, and so we say that array is of fixed length. So, now we will see how to declare arrays in your code. So, whenever you are going to use an array, we need to specify its data type, what its size, what its name is going to be, that is array name, and then you may have to specify the size within square brackets followed by a semicolon, provided you use C as the programming language. So, here type specifies the data type which we are going to use. So, we may want an array to have either all the elements to be of integer or all the elements to be of floating point type. Accordingly, you may have to specify any of the available types, and then you may have to specify size, which is actually an integer constant, which actually tells how much amount of memory has to be reserved for this particular array for that particular data type which you have specified. So, here I have provided two examples. In the first example, I have declared an array A1 of size n and its type is integer. So, you could see that for A1 9 locations are reserved, contiguous memory locations are reserved, and all of them are homogeneous and of type integer. In the second example, you could see array A2, its size is 7 and its type is character, which means compiler will allocate memory for this array A2, that is it would reserve 7 consecutive memory locations in order to hold elements of type char. So, of course, you may have to know some of the facts associated with arrays. So, in the first example, I have shown int marks of 50. So, by seeing this declaration statement, you will know that we have an array named marks with size 50 and type integer. So, whenever we are not sure of the size of the array to be used in our program, we always define a higher value for the value of size. So, we define the size to be of some larger value instead of the actual size of the array which we are going to use. In the second and the following examples, I have given you some of the things which are illegal with respect to the usage of arrays. So, in the first thing x of 50, so here in that case x of 50 is illegal just because I have defined an array of size 50, which means the indices will span from 0 to 49, and so that is going to be illegal. And x of minus 1, it is illegal just because we can't have an index to be a negative number, and x of 100 is actually out of bounds of the array. We have defined an array of size 50, but we are accessing some location beyond its size, and so we say that it is out of bounds. And in the following example, you could see that we have used int n and int marks of n. Int n is a variable and we have not defined the value for n. We have not initialized the value for n, but however in the next declaration we are saying int marks of n. So, we can't use we can't have such a declaration without initializing n to some value. And on the right you could see that A is equal to B when A and B are arrays. So, assigning an array to another array straightforwardly like variables is not possible, and if A is equal to B, which is not valid in the case of arrays just because we can't straightforwardly compare two arrays. And printf statement, we cannot print array as such just like we print a variable. In order to print some elements from an array, then apart from array name we need to specify its index. So, these are all some of the errors which we may encounter or some illegal ways of using arrays. And here also I have given you some invalid usage of arrays. So, here the first example is float sales of 10, which means I have an array named sales with size as 10 and its data type is float. So, the following are some of the invalid assignments which you could do with an array, like sales is equal to 17.50. There the assignment is not possible because I did not have mentioned the subscript, where in that array the value 17.50 has to be placed, that is missing there, the position information is missing there, and so it is an invalid array assignment. In the second, I have used a negative index, sales of -1, which is not possible, and in the third, sales of 10 is equal to 17.50 is illegal, just because we have defined the array size to be 10, and so the index would span from 0 to 9, and so sales of 10 is just an out of bound. And in the fourth case, sales of 7.0, it is also invalid, just because an array's index can't be a floating point value. And the fifth case, sales of A, we can't have a character as an array's index. And in the last case, sales of 7 is equal to A. Assignment of a character to a floating point array is also mismatch in data type. So, that is also one of the invalid usage. And conversion can always occur. For instance, in the last example, sales of 7 is equal to 17. In that case, 17 is an integer, but we have declared that array to be of floating point type. In that case, implicit conversion will happen. So, such conversion is possible in an array. Next, we will see how this array is actually stored in memory. So, as I was mentioning before, array is a collection of elements, and all the elements in the array are of the same data type, and so we say array is homogeneous. And for an array in memory, memory is allocated consecutively. So, here you could see that we have an array A, and it has some n number of elements, and so here the first element's address, we call it as the starting address for that array in memory. So, for whenever we require for some memory to be allocated for an array, the array we call the first element's address to be the base address of that array, or it is the starting address for that array. And you know, array's index always starts at 0, and so we say that the base address is nothing but the address of the first element of the array. In our case, it is going to be A of 0, and thereafter every element will be at regular displacement of the size denoted by the data type. For instance, if suppose we declare an array to be of type integer, then we can assume that for every value of type integer, 4 bytes of memory is required. In that case, if I have 10 elements in my array, altogether 40 bytes will be reserved for that array. 10 into 4 is 40, and so 40 bytes will be reserved for that array. And when I look at the positioning of elements, the first element would be at position x, the next element would be at position k, where k is 4 in my case, and the subsequent elements will be at I into k, which is where I denotes the position. So, the second element is available at 2k, third element at 3k. Likewise, we will have all the elements positioned at x plus I into k. If suppose I want to pinpoint to a particular element within an array, then I may have to specify its index, or I may have to count from its starting address. So, its starting address is x. So, I would say that I want a position, I want element at position A of I, which is x plus I into k. So, this is how actually your array would appear in memory. So, in the first diagram, you could see that I have 5 elements, and the starting address of that array is 1024, and which means the first element of that array of 0 is at memory address 1024. As I said, since it is an integer array, every element would require 4 bytes, and you could see that every other elements are available at a regular displacement of 4. So, here as we have the starting address as 1024, the last element would be available at 1040. And on the second diagram you find on the right, you could see that we have mentioned how the index would look like, and you see every time the index starts from 0. Here we have 5 elements, it starts from 0 to 5, and the actual values in that array are 8, 6, 7, 13, 8 and 19. And you know the base address of that array is 108, that is the address of the first element of that array. And in order to compute the address of the successive elements, we use the same formula, which is base address plus I into k, that is the size reserved for every element. In our case it is 4. Say for instance, if I want to find the address of the 4th element, we compute the base address as we compute from the base address as 108 plus 4th element, which is 4 into 4. So, its actual address is 124. So, this is how we look at every element's memory address from we compute the address of every element in an array from the base address. So, next is how to do initialization of arrays. The general form is that we specify its type, its name, its size, and in order for initializing it, we may have to add this equal to symbol followed by set of values in that array enclosed within braces and terminated by a semicolon. So, here I have given 2 examples. In the first example, we actually define an integer array of size 5, and it has 5 elements which are all separated by comma. And the next I have a character array, and you could see that all the characters are separated by comma and enclosed within braces. And alternatively, you could also do it the way I have put it at the last. Float total of 5 is equal to 24.2 comma minus 12.5 etc. So, there you could see that the size of the array is 5, but I have given only 3 values within. So, it means that the first 3 locations in that array will be initialized to these 3 values, and the other 2 elements will be automatically set to 0. And in the other case, you could see that I have given float total of 5, and I have taken turn to initialize every element in that array. So, in order to specify every position of an array, we may have to refer it with the help of its index. So, total of 0 denotes the first element in that array. So, I have put 24.2 there. Likewise, we can do for rest of the elements in that array. At times, we may even commit a mistake, like we have defined the array size to be 5, but we may have mistakenly specified 6 elements here in this case. So, if we have done so, then the excess element will always be ignored. In that case, the array will be created with just 5 elements, the first 5 in that sequence. And if suppose here you could see that in the next example, you could see that the size is missing. So, it is also possible to initialize arrays without mentioning the size. We can have just the type, the name of the array, and we do not even need to specify the size, but we can straight away proceed with initialization. So, in that case, the flag array will be created to be of type integer and with just 4 elements, just because we have specified 4 values within the braces. So, whatever elements we actually specify within that braces, the compiler will automatically allocate space for that many elements we have explicitly mentioned as a part of initialization. So, now we are going to study the first basic operation in an array, namely accessing arrays. So, accessing arrays in the sense we are going to have a look at or going to access any one of the elements from that array. So, in this case we have a declaration like int a of 25 comma b of 25, which means we are having 2 arrays of size 25 and all of them are of type integer. In the first example, what I have done is we have taken we have taken an attempt to move elements from array B into elements into array A. So, here as both the elements have 25 spaces, and just because we have 25 values in the array B, we have set up a loop to count from 0 to 25, and for every value of j, the corresponding value from array B would be moved to the corresponding position in array A. Thereby, all the elements from array B will be copied to array A. In the second example, I have shown you the way to read one element at a time from an array. So, here we have made we have got input from the user, and for that we have made use of the scanf statement. So, I want to get values for array A from the user, and that too, since array's capacity is 25, I may have to access, I may have to get input from the user 25 times and place it in the respective location in that array. For that we run a loop that runs 25 times, and in order to pinpoint to specific location, we use that ampersand symbol before array's index. And if suppose I want to print every element from that array, so similarly instead of scanf, I could use a printf and take turns to print all the elements in that array by setting up a loop that runs for specified number of times. And in the example you see on the right, you could see an array, my array, that has 4 elements in it, where index runs from 0 to 3. So, if suppose I want to access the third element from the array, then I may have to specify its index, my array of 2, in order to access the value of 55 from that array. Having seen about one dimensional arrays, at times there may be a need to use even 2 dimensional as well as multi-dimensional arrays. For example, if you are given with a table of values, then it is necessary that we have to go with 2 dimensional arrays. So, here in this case you see an example where we have the marks of 3 students for 5 subjects, and so for that sake we have created a 2 dimensional array named marks with 3 rows and 5 columns. And so, we have used 2 indices here, I and j, where I would span across rows and j would span across columns. And we have 5 subjects, so index starts from 0 to 4, and we have 3 students, and so the index spans from 0 to 2. So, this is how we actually use a 2 dimensional array for storing information which we want to have in the form of a table. So, the general form of declaring a 2 dimensional array is just like 1 dimensional array. The only difference is that we specify type, we specify name. Instead of specifying one size, we will be specifying 2 sizes, one corresponding to number of rows and other corresponding to number of columns. So, here this is how we access a 2 dimensional array. As I was telling you before, for any array you need to know the base address. In case of 1 dimensional array, the position of a of 0 actually is the base address. In case of 2 dimensional array, the position, the base address is the address of the element at a of 0 0. So, where first 0 denotes the row index and the second 0 denotes the column index. So, here in this example you could see I have 3 rows and 4 columns. Altogether the array contains 12 elements, and you could see that all the elements of array, the first row would be placed at consecutive locations first, followed by all the elements of second row placed in consecutive memory locations, followed by the third row. So, that would be the arrangement of elements in a 2 dimensional array in memory. So, in order to access specific elements, I may have to specify 2 indices, one corresponding to row and other corresponding to column. For instance, if I want to access the element 87, so it means it is available at first row and third column. So, I may have to specify its position as a of 0 3. So, that would help me to access 87 in my program. And the way 2D arrays are stored in memory, as I said before, the elements are stored usually in row major order, which means all the elements of first row would be stored in sequence, followed by elements from second row and so on. So, here in order to specifically know the memory address of every element in that two dimensional array, we may have to use A of I j. We can compute the address of any element A of I j as address of the base address of the array, which is address of x, plus I into C plus j into k, where I is the number of rows you have, j is the number of columns you have, and k is the number of bytes allocated per element. So, A of j is a address of x, which is the base address of that array. So, A of I j is address of x, which is the base address of that array, plus I, which is the I into C, where C corresponds to the number of columns and j corresponds to number of rows, into k, which is the size defined for the particular data type. So, at the bottom you could see how the elements actually are placed in memory. As I said before, all the elements in row 1 would be placed, followed by row 2, followed by row n, etc. So, the way we access 2D arrays, we are going to do the same as we did for 1D array. So, here first example I have shown how to read one element at a time into a 2-dimensional array. So, the only difference is that we add one more index other than what we had for 1D, one to denote row and other to denote the column. Likewise, we can print every element in a 2D array just by having two loops, one that spans across rows and other to span across columns, and in order for printing we have the printf statement with us. Next is the second operation which we normally do on arrays, which is traversing the array. Traversal in the sense how we access all the elements in that array exactly once. So, we start from the base address or the first element in that array and navigate towards the end of that array. So, here you could see I have 5 elements in that array and I have used a for loop to scan or to traverse of all the elements in that array one after the other. I could traverse all the elements of that array from beginning till end. So, the loop starts from 0 and runs till n, and I could access every element one after the other by navigating through this for loop. So, having seen what one dimensional and two dimensional arrays are, how to access arrays, how to initialize, and how these arrays are actually positioned in memory. Now, let us see some of the questions which we could expect from an arrays to test our understanding on arrays. First is, let us see an array, we have an array of integer of size 10 and compiler then will allocate memory for it. So, in which memory, that is cache, main or secondary memory, the memory will be allocated. You know very well, whenever a program is put to run, the program, its instruction and data are supposed to be available in main memory. So, the data will be available in main memory. If it is stored in main memory, then in which part of the main memory would it be stored, whether it would be in data area or heap area or instruction area. So, you know, whenever a program is ready for running, we will have 3 spaces associated with it. One is instruction area, which will contain the instructions which are part of the program. The next is the data area, which holds the data, and heap area, probably it would hold stack and other data pertaining to dynamic memory allocation. Since we are dealing with arrays, our array would be maintained in data area of main memory. And the third question is, how much memory would be allocated for this array? As you know, it is an integer array of size 10. If suppose your compiler reserves 4 bytes for every element, then it is going to cost 4 into 10, which is 40 bytes. And will it be stored in contiguous locations or distributed at random locations in memory? We know for sure, by definition we know array elements are stored in contiguous memory locations. The second question is, we have two arrays x and y, one is of type float and other one is of double, which should take more amount. you know the reason for this. For floating point, your compiler normally reserves say 4 bytes, and double it may reserve 8 bytes. In that case, 4 into 100 is 400. For y it would be 8 into 100, which is 800. So, ultimately the array of type double would take more amount. The third question is, suppose you have declared an array of size 100 and type long, and assume that every word is taking 2 bytes. If suppose the starting location is 1124, which is the base address, what would be the location of the 8th element? So, first base address is 1124 plus every element takes 2 bytes, and we are looking for the 8th element. So, 8 into 2 16. So, it is 1124 plus 16, the answer would be 1140. The fourth question is, suppose we want to store the following data into an array which is declared as char a to z 100, and is it possible to store them? We have values as 11, 0, a, capital A, small a. Since this array of type char, we are supposed to store only characters there, and we can't have these varying types. We learned by definition that array should have homogeneous elements, so it is not possible. And the fifth question is, what will be the memory location of a of ij in memory if the starting location of the array is x and the 2D array is stored in column major order? Assume each element of the array needs w words of memory. So, here there is only a slight change in the formula which we saw before. Just because it is column order, we revise it as x plus j into m plus I into w. So, this is the formula which we are supposed to use to compute the memory location of individual elements in this 2D array. Next, I have few questions to spot errors in the code. So, in the first question, we have two arrays A and B, A being a 2-dimensional array and B being a 1-dimensional array. So, in the first question, you could see a scanf statement that reads values into array B, and you know array B is of type integer, but the format specifier is %f, which is the mistake there. And in the second question, you could see we have two for loops, and we have a of ij is equal to 0, which is an assignment statement. And you know in the second for loop, the index instead of spanning the index variable is I instead of j, which is the error there. And in the last one, we have a scanf statement to read values into array B, and there you could see that the array spans from 4 to 0. You know the array size is 4, so it can have indices from 0 to 3. So, starting from I equal to 4 is invalid there. So, that is the error there. I hope with these examples, with these questions, you may be more thorough with whatever concepts we have learned so far. To summarize, we have seen about arrays, which is a basic data structure. It is a linear data structure, and in an array, all the elements would be stored in contiguous memory locations. And in order to use an array, first of all, we need to declare it in our program, and always the array size is going to be fixed, and we cannot revise later at point of time. And in order to access particular element from an array, we may have to use an index, and always an array's index starts from 0. And we learned two basic operations here, how to access elements using its index, and how to navigate through all the elements in that array, for which we may have to use traversal, where we have a loop that will run from 0 to the end of the array. And when we talk of applications, like when we want to store and process some list of elements like student records, we may have to use an array. If suppose we want to implement other data structures which we are going to learn in future, like stacks and queues, then for implementation purpose also we may be using arrays. And for solving other kinds of algorithmic problems like sorting and searching, we will also be using arrays. So, in the next class we will be exploring other operations which we could do on arrays.